This is addition of polynomials. Here is the first example. This problem is asking you to add a quadratic trinomial to a quadratic binomial. When it comes to addition or essentially subtraction of polynomials, all you have to do is combine like terms. Keep in mind that like terms are those that have the same variables or letters, and those letters have the same exponents. So looks like I have the 3 with x squared and the 2 with x squared. We combine those to 5 with x squared. The next thing here is 4 with an x. I don't have another term anywhere with an x, so I'll just bring it down. And then I also have the -1 here and the -11 here. So -1 and -11 together is a -12. This is it. Now let's look at subtraction. So here is a similar question. The only difference is, well, of course, the number of terms, but also this negative sign in front of the second polynomial. Before you start combining like terms, if your problem is the subtraction problem, I want you to write the problem over without parentheses. The first polynomial will stay exactly the same. However, the red negative sign will make every sign in the second polynomial switch to the opposite. So this 2x to the second inside of the parentheses is positive, but the negative symbol will make it a -2x squared. Then a -8 was negative, will make it +8. The next one was +3x, we'll make it a -3x. And finally, a -15x to the third will become a +15x to the third. Now, once you rewrite it, you avoid the issue of not getting the correct signs at the end. We can collect like terms now. So you have a 5x to the third and a 15x to the third. Together it will make you a 20x to the third. Then you have the single -2x to the second. There are no other terms with x squared, so I'll just bring it down. The next one is the +2x, and you also have this -3x. So together that will make you a -1x, or you could just say -x without writing the 1. Finally, -11 and +8 together will make you a -3. This is it. This is how you subtract. The next few questions will deal with multiplication. For multiplication questions, it is important to remember the very first property of exponents. That property allowed us to combine two bases that were the same, and they were being multiplied by each other, this a and this a. And if those same bases had exponents, what we could do is we could keep that base as is and add the exponents. So keeping this in mind, let's go ahead and look at the first example. All of the next few questions will ask you to multiply, and here you are asked to multiply this monomial of the 4th degree by this trinomial of the 2nd degree. What you will do is essentially the distributing, keeping the property here in mind. So your first step will be to take the monomial in the front and multiply it by the first term on the inside. 3x to the 4th times 2x to the 2nd will result in 6x to the 6th. To get this answer, what I did was I took the 3 and multiplied it by this 2 to get this 6. And then I kept the x. So you multiply these two x's, you keep the x. But then you are adding the 4 and the 2 for the exponents to get this 6. Now we'll go back to 3x to the fourth and we'll multiply by this 2x. Now this 2x looks like it has no exponent, but again, if your letter doesn't have an exponent, you keep in mind that it has that exponent of 1. So for the second blue arrow, you will be multiplying this 3 here, by this 2 again, so that's a positive 6. And then you will keep the x and you will add the exponents of those x's, so the 4 and the 1, that will make you a 5. Finally, we'll go back to our 3x to the fourth and we'll now multiply it by this negative 2. So there are no x's by the negative 2. You'll just have to multiply 3 by negative 2, this 3 by this negative 2, negative 6 again, and you just bring down the x to the fourth that was already by this 3. This is it, you multiplied. Let's look at another example. Well, here is multiplication of 5yw here. I will go ahead and add the exponents of 1 to each of these letters, and then I will also go ahead and add the exponent of 1 to the w that is on the inside in your leading term. So let's go ahead and multiply 5yw by 5y to the third w. 5 and 5 will make me 25. The y will have the power of 4 because I am adding this 1 and this 3. And then the w will have the power of 2 because I'm adding this 1 and this 1. Now I will multiply 5yw, that is still in the front, by this 2y to the second. So 5 times 2 will make me a positive 10. Y to the first, so this power of 1, and y to the second will multiply to y to the third. And then the w here will stay as w. The final term, all you have to do is multiply this 5 by this 4, since 4 doesn't have any letters, so plus 20yw. Here is the multiplication of two binomials. Each is linear because the degree is 1. This problem is requiring you to do the same work we did in number 1 and number 2, but twice. First, you will do it with this x to the power of 1. So I'll take x to the power of 1 and multiply it by this 2x to the power of 1, which will make 2x to the power of 2, since you're adding these exponents. And then I will also multiply this x to the power of 1 by this positive 5, which will make a positive 5x. Essentially to the power of 1, you don't have to write it here. Now we will repeat this work, but the distributing will be done by this negative 2. So I will distribute a negative 2 and multiply it first by positive 2x. So that's a negative 4x. And then going back to the negative 2, I'll multiply it by this positive 5, and that's a negative 10. This question is not complete because you have a pair of like terms that you have to combine. Positive 5x and negative 4x together will make you a positive 1x. So 2x squared plus 1x, or you could just write x minus 10 is your final answer. Question number 4 is similar, but it has this extra 5y in the front, and I wanted to mention that if you have a monomial in front of the two polynomials that are being multiplied by each other, you will need to multiply by this 5y, but not both binomials. You will not be doing this. Do not do this. Instead, I want you to take that 5y and multiply it only by the first binomial. So distribute it inside of the first binomial only. That will create 20y to the second plus 25y. And this is now your first polynomial. I'll bring down the rest of it. And we will repeat the work we did in question 3. 20y squared times this y to the power of 1 will be at 20y to the third. 20y squared times negative 5 is negative 100y squared. 25y to the first times y to the first is 25y to the second. Finally, 25y times negative 5 is negative 125y. This problem here also has a couple of like terms, so I will combine the negative 100y squared and positive 25y squared, and that turns into 20y to the third minus 75y squared minus 125y. This is your final answer. Here's your question number 5, essentially the same thing, but the second polynomial has 3 terms and you will be distributing this u, remember, has the power of 1 into each of the 3. And then you will do the same with this negative 1. So we'll start by completing the 3 black arrows that I already have. Again, keep in mind that each u that does not have an exponent has the exponent of 1 for the purposes of multiplication. So we'll go by this first arrow. U to the first times u to the second is u to the third. U to the first times u to the first, add the exponents, positive u squared. U to the first times 1 is positive 1u. You can write to the first, but you don't have to. Now we'll distribute negative 1. Negative 1u squared, negative 1u, and negative 1 times this one is negative 1. Now we will be collecting like terms. You have 1u and negative 1u, they cancel. And then you also have this 1u squared that's positive, and this negative 1u squared, they also cancel. All that's left is u to the third minus 1. And then one last final question here, number 6. 3x minus 2, the whole thing squared. The most common mistake that I see students make is squaring 3x and squaring 2 separately and leaving that as your answer. This is incorrect. The idea behind squaring a binomial is multiplying it by itself. So once you write out 3x minus 2 times 3x minus 2, you have to do our double distribution. So 3x times 3x, that's 9x squared. 3x times negative 2, that's negative 6x. Negative 2 times 3x is negative 6x, and negative 2 times negative 2 is positive 4. Another common mistake I see students make is canceling the 6x in the middle. They don't cancel because they're not opposite in sign. You have to combine them into a negative 12x. So the final answer here will be 9x to the second minus 12x plus 4.